In this video, we'll be talking about special products that can result from foiling. When we FOIL each of these out, what we end up with is the following. So this is me skipping the foiling. What we would end up with is u and u, so the first terms would be u squared. The outer term would be minus u times v, but then the inner term would be a positive u plus u times v. So those would actually cancel out with each other in the end, and then I could just move to the last term, which would be minus negative v squared. Similarly here, if you understand that this is really u plus v times u plus v, please don't forget that. That's what the square really means here. Then, foiling this out, you would end up with u squared plus 2uv. This is both the outer and inner terms put together, and then a v squared. Similarly, if you do u minus v times u minus v, you end up with u squared minus 2uv plus v squared. Finally, for the cubes, what we would end up with is, again, here you're basically taking u minus v squared and multiplying it by yet another u plus v squared, and multiplying it by another u plus v. So if I multiply this whole thing by u plus v, what I end up with is u cubed plus 3 u squared v plus 3u v squared plus v cubed. Similarly, here I would end up with u cubed minus 3u squared v plus 3u v squared minus v cubed. Notice that when you throw a negative in, the sign alternates. It is really worth memorizing these, as these can really help you when computing things. Namely, if you recognize here that the sign is different, you can immediately say, oh, well, recognizing that special form, I know that this is 5x squared minus 9 squared. But then that is just 25x squared minus 9 times 9 is 81. So greatly shortens your work. You can also use the same thing here. The important thing here is to recognize that the x plus y, if you consider that as one term together, you can actually notice that these are off by a sign. So this is x plus y squared minus 2 squared. Well, x plus y squared, we can use another one of those products to find that this is actually the same thing as x squared plus 2xy plus y squared, and then of course minus a 4 on the end. So now it's time for you to try an example. Go ahead and find each of these products. It's very similar to the last example. On the count of 3, I'll go ahead and reveal the answer. 1, 2, 3. So you see that here, for instance, I actually, by expanding all this out, I end up with this form, but it's worth noting that it's good to put it in standard form, and so we go ahead and we rearrange it this way so that it's in descending order of all the powers. For practice with working with these special products, be sure to see page A33 of the textbook and work out numbers 3, 4, and 15 through 36. And in our next video, we'll be talking about polynomials with common factors, so we'll be starting factoring.